Welcome to another video. Today is another episode and we are going to look at integration by partial fractions. Don't forget to press on the notification bell, subscribe, share, like, and then I'll be very glad to give you more videos as well. So right here, let's look at our first problem, which is this right here. We want to find the integral of this particular function. Of course, we have 17 minus 4x all over x minus 2, then x plus 1 dx. Right. So right here, we know that we cannot integrate this right away. So we have to apply the integration by partial fractions. Right. So this right here, we have to find the partial fractions of this particular function. Right. So let's first do that. Then we can go ahead and do the integration. So right here, right? This in the partial fraction form, this is how you represent it, right? You know that our x is a linear function, right? All over x minus 2 plus the second one too is a linear function, so plus b all over s plus 1, right? So we find the value for the variable a and b, right? So when we do that, that means that we are going to look for the common denominator right here. So when we do that, you can say that this is equivalent to, right, a into x plus 1, right? That is the LCM for this. When you do that, plus b into s minus 2 all over s plus 1 s minus 2, right? So we can see clearly that this denominator is equal to this denominator. So we don't really care about the denominator. So we equate the numerators, right? So let me write this here. All over x minus 2 s plus 1, right? So we can see that our denominators are the same. So what we do is equate this to this, right? So when we do that, we're going to have 17 minus 4x equals a into x plus 1 plus b into x minus 2, right? So right here, we have to assume that if x equals s plus 1 equals 0, right? S plus 1 equals 0. This implies that x will be equal to negative 1. So if x is equal to negative 1, then we can put that value in place of x and find one of the variables, right? So we have 17 minus 4 into negative 1. That should be equal to a into negative 1 plus 1 plus b into negative 1 minus 2, right? So when we do that, they're going to have 17 minus 4 times negative 1, and that's going to plus 4, right? Should be equal to, this is minus 1 plus 1. So we're going to have 0 here. So 0 times a is going to be 0. Then we go to the b, right? So we have b into negative 1, negative 2, and that is negative 3, right? So we can say that our b, negative 3b, should be equal to 17 plus 4, and that is 21, right? So we can say that our b will be equal to 21 divided by 3, that is negative 7. So right here we have our negative 7 as our b. So once we are done finding the b, we can go and substitute and find the a. Or we can say that when x minus 2 equals 0, that is this right here, then we can say that our x equals 2. So if x equals 2, then we can also substitute that into this expression or this equation, then find for b as well. So 17 minus 4 into 2, that should be equal to a into 2 plus 1 plus b into 2 minus 2, right? So we have 17 minus 4 times 2, that is 8, should be equal to a into 3 plus this right here will give us 0, right? So we have 3a should be equal to 17 minus 8, and that is, of course, 9, right? So this divides this, and then we can say that our a is equal to positive 3, right? So once we are done finding the values of a and b, we can go ahead and substitute in place of this, and then we can go and insert into the integrand and find the integration of this particular function we see right here. So this, we can say that by replacing a and b, we can say that we have a, which is 3 right here, all over x minus 2, plus our b, which is minus 7. So we have minus 7 on x plus 1. Right, so we are going to replace this by this. Right, very clear. Good. So right here, we have this is equal to 3 on x minus 2 minus 7 on x plus 1, right? Dx. So now we can handle this perfectly without any struggle, right? So we can go ahead from here, right? So now we can integrate this function, right? So this, to make work so easy, we can say that 3 on x minus 2 minus 7 on x plus 1 dx, right, is the same as 3 on x minus 2 minus, or we can say plus, integral of negative 7 on x plus 1 dx. Right, we integrate it term by term so that our work will be much easier. So that we know that the integral of 3 on x minus 2, the integral of 3 on x minus 2 dx, right? We know that we can have 3 out, 1 on x minus 2 dx, right? And this right here, we know that it's going to be ln, right? Ln of something, right? So, of course, this is a linear expression, so it's going to possess the ln, right? So this is going to be 3 ln into x minus 2 right here, plus a constant of integration, but we don't need it at this point. When you are done with everything, then we add it up, right? So this is the integral of this right here. Now let's go ahead and find the integral of this particular one right here. So right here we can say that negative 7 out, we have 1 over s plus 1 dx, right? So of course the integral of 1 over s plus 1 is equal to ln into s plus 1 right here, but we have -7, so -7 right here, plus a constant of integration. Of course, I said it's not very necessary at this point. When we want to add or, then we add one constant of integration. So this we had 3 ln into s minus 2 plus -7 ln into s plus 1 plus c. So this is the approach to go through and find the integral of this particular function. Of course, it's very easy, but you have to understand the integration techniques and know the partial fractions as well, and this work will be very, very easy. I know where people will be stuck, where I got lean into this, it's very simple. You have to follow the procedures in working this, right? You know that when you want to find the integral of 1 over x minus 2, you can say that u should be equal to x minus 2, right? So we can say that du is equal to dx, right? So if this is true, then we can say that 1 on u, this is u, right? And our dx now is the u, right? But we said that we all know that 1 over u is ln u, right? And earlier on, we said that u should be s minus 2. So we have ln into x minus 2 plus a constant of integration. So that is how we came by this kind of solutions. So thank you very much for watching. I really appreciate your time. Don't forget to press on the bell, subscribe, share to your classmate as well. Bye-bye.